In Chapter 8, what we're going to talk about is solving a system of equations. In 8.1 and 8.4, which is solving a system of inequalities, we're going to do some graphing. But for the other two, 8.2 and 8.3, we're going to use different methods. We're going to start with graphing because that's what we were doing in all of Chapter 7. So let's go ahead and take a look on page 572 at problem number 8 that I have listed here. What we want to do is we've got these two equations, x minus 2y equals 8, and then 3x minus 2y equals 12. We want to graph those two and find out where they intersect. So taking the first one, if we set up the xy coordinates, where x is 0 in one case and y is 0 in the other case, let's go ahead with x minus 2y equals 8, 0 minus 2y equals 8, minus 2y over minus 2 equals 8 over minus 2, and therefore y is equal to negative 4. In our second solution, starting with that original quantity, now we're going to substitute 0 for y. So we have x minus 2 times 0 equals 8. Therefore, x is equal to 8. Once we've done that, what we're going to do is go ahead and plot those 2 points. On the x-axis, we're going to plot 0 and y minus 4. So that's going to be down here. And then the other one, when the x is 8, or y is 0, x is all the way out to 8. That's clear out here someplace. And then we go ahead and draw a line between those two. Now, I would draw the line all the way through the point, but I'm going to try and do a couple of these, so I'm going to keep this line right in here someplace, if I could. It's not drawing very well for me, but you get the point. All right. Now, in our second part, we have this equation 3x minus 2y equals 12. Again, we want to set up x and y coordinates. X, y. X is 0, y is 0. Now, if x is 0, what we're going to get is 3 times 0 minus 2y equals 12. So that's negative 2y equals 12. Dividing both sides by negative 2, we'll get 12 over negative 2. And now we get y equals negative 6. In the second part, erasing this again, taking our original equation, only this time we're substituting 0 for y, we'll get 3x minus 2 times 0 equals 12. Therefore, 3x equals 12. 3x over 3 equals 12 over 3, and x equals 4. Now we go ahead and plot those points. And those points are x is 0, y is negative 6. That's clear down here. And then when y is 0, x is 4. That's up here. Now, if we draw a straight line between those two, we'll get something like this. And now, where those two intersect, that point we have to read on our graph. And, according to the book, that point happens to be x is 2, and that looks pretty close, and y is negative 3. That's the solution for both equations. Now, what you want to see is, does that really hold up? So we're just going to check this one problem. I'm going to erase all this other part, and let's take a look at our solution, where we said x is equal to 2, y is equal to negative 3. Does that work? In the first one, where we had x minus 2y equals 8, now we substitute for x, 2, minus, and 2y was negative, or y was negative 3. Let me write that again, I'm sorry. X minus 2 times negative 3 equals 8. Obviously, if you hurry things, you can make mistakes, and I've demonstrated that now. So 2 plus 6 equals 8, and 8 does equal 8. So that works as a solution for that first equation. Now looking at the second equation, 3x minus 2y equals 12. If we substitute for x, 3 times 2, and then we substitute for y, negative 3 equals 12. What we get is 6, and the negative 2 times negative 3 gives me plus 6 equals 12, and 12 equals 12. So that solution, 2 and negative 3, solves both both equations, and therefore you've solved a system of equations through graphing. All right, let's go ahead and erase because we want to take a look at another problem. We want to do a couple of these because then once we've demonstrated a couple, I think you've got how it works. We'll go ahead and erase our little graphs here. And let's drop down and take a look. Oh, I'm sorry. Rather than drop down, let's go over to page 573. Take a look at 14. This one's not too difficult. 2x minus y equals 8. And the other formula happens to be x equals 2. Setting up for the first one, x, y, 0, 0. If we have 2 times 0 minus y equals 8. If you have minus y equals 8, you would divide both sides by minus 1, or you could just change the sign. Makes a positive y, makes that a negative 8. All right? Now, what if y is equal to 0? Well, then what you have is 2x minus 0 equals 8, 2x equals 8, 2x over 2 equals 8 over 2, and x equals 4. Now let's go ahead and plot those points. If x is 0, y is minus 8. It sits way down here. But if y is 0, x is 4, and I've already got a point there. So what I can go ahead and do is draw my graph from that minus 8 up to that plus 4, and I'll just draw a quick line right there. Now, the other thing then is this second formula. And that second formula right here, x equals 2, there is no value for y here. So what that turns out to be is x is 2 right here, no matter what the value for y. So we just draw a straight line, and that's the only reason that I demonstrated this to you. It would be a straight line. It would come down like this. All right? And where they intersect should be at the point x is 2, has to be because in the first one, and y turns out to be negative 4. May not look like quite on my graph, but it's close enough. All right, we'll do one more, so I'll erase this. And the last one we're going to do is 16. Lost it for a minute there. We're going to do number 16, so I'm going to erase all this other stuff. If you can follow this, you should have no trouble with your homework. In 16, what we have is x minus 6y equals 6. And our second formula is minus x plus y equals 4. Setting up coordinates again, x, y, 0, 0. In the first one, if x is 0, then 0 minus 6y equals 6. Dividing both sides 6y over negative 6 equals 6 divided by negative 6. What we get is y equals negative 1. Then, if we do the second part, where we substitute for y, we'll get x minus 6 times 0 equals 6. Therefore, x equals 6. In our second equation, setting up x and y points, and you may want to plot that first one before you do the second part, but I'm going to go ahead and do that. 0, 0. So, minus 0 plus y equals 4. Therefore, y equals 4. Good. In the second part, what if y equals 0? What we have here then is minus x plus 0 equals 4. So minus x equals 4. We divide both of those by a minus 1. We would get x equals minus 4. So we go ahead and plot these. The first one we're going to plot has the points x is 0, y is minus 1. That sits right here. And then when x is 6, y is 0, that turns out to be fairly flat. You know, it's got a very low slope. It's positive because it's going upper right to lower left. This is a positive, but I think that slope's like 1/6 or something like that. There's that one. Then we plot the second one. If x is 0, y is 4, that sits up here. And then when x is minus 4, this computer is hiccuping on a regular basis. X is minus 4 when y is 0. That sits here. When we go ahead and plot that, what we see is a line that looks like this. Now those haven't intersected yet, so what I need to do is I need to extend that first one. So what I'm going to do here is erase a little bit of it so I can go ahead and extend that out. What that looks like is something on the order of x is minus 7 or minus 8. I'm not sure which. My graph is not that accurate. Yours is much better. And y then turns out to be about negative 3. And let's see what they have in the way of results in the book. What they say is that it's minus 6 and minus 2. So my graphing isn't the most accurate. However, when you graph using your own graph paper, you will find that you'll get a much more accurate reading because yours is all squared up. So there you have it, solving a system of equations through graphing.